Hello guys, today we're going to talk about probability, which is how likely something is to happen. Something to happen. Okay, so say I have this dice here. Okay, so this dice has two sides, each with a value of 0, 1, and 2. Probability means how likely am I to roll one of the faces that has a 0, right? So we have 6 sides to a dice, right? So we have a 6, right? So if I have two faces with 0, I have a 2 out of 6 chance to roll a 0. Same thing with a 1 and a 2, okay? So I have a 2 out of 6 chance to roll a 0, 1, or a 2. So let's see if I can roll a 2. Okay, no I couldn't, I got a 0. So, how many times can I say I could roll a 0? 2, right? So you're going to do 2 over 6. It's how likely you're going to roll a 0. Okay? So 2 out of 6 is how likely you're going to roll a 0. Now, we're going to go over something. It has to do with probability. An independent event. Is an event that is not affected by an old event, okay? So a previous event can't affect a new one. Okay, so it cannot affect a new one. So it's like rolling a dice, okay? So for that first roll, I got a 0, right? Now, can that 0 affect my next roll? Let's see if it does. Well, I got a 2 this time, okay? So it does not affect my next roll, which means it's independent event. Now, if independent event is not affected by a previous event, a dependent event is affected. By the previous one. Okay, so take example. I have a bowl of 20 Jolly Ranchers right here. 5 blue, 5 red, 5 purple, 5 green. Okay? So a dependent event is affected by a previous one. So if I go and I pick out one of these Jolly Ranchers, right? And I eat it. I'm not going to have 20 Jolly Ranchers left, right? I'm only going to have 19 now. So, when I picked this red one, I had a 5 in 20 chance of picking a red one, right? But now I only have 4 red left. So now I have a bigger chance of picking another color. Okay? So let's pick another color. I picked a purple, right? I still have a 5 and 19 chance of picking that purple. And the reason it's 19 now instead of 20 is because of that dependent event. I took that red one out and I ate it. So we only have 19 left in the bowl. And now I took a purple one out, right? And I'm going to eat it. So our new, we have 18 left, right? So our new chances of picking a red one out is 4 and 18. Okay, 4 and 18. You have a 4 and 18 chance of picking a red one out. We also now have a 4 and 18 chance of picking a purple. Because we both chose a red and a purple. Now, we still have a 5 and 18 chance picking a green. And we still have a 5 and 18 chance of picking a blue. Okay? So the dependent event is not only did I reduce the number of Jolly Ranchers, but I also reduced the number of red and purple left. So now I have less chance of picking a red and a purple because I took those out and I ate them. So now we're going to go on. Okay? So the same thing of building off the idea of a dependent event. We're going to talk about probability without replacement. Remember, I have 20 Jolly Ranchers, right? So I have 5 red, 5 blue, 5 green, and 5 purple. Okay? Now, that gives us a total of 20, right? When you think of replacement, you're putting things back, right? So without replacement means, just like the previous example with the 20 Jolly Ranchers, whenever I pick one, which is a blue, I'm going to eat that blue. I now only have 19 left, right? 19 Jolly Ranchers left. and 4 blue ones left. Okay? So I'm not going to put that blue Jolly Rancher back. I'm going to eat it. So now, instead of having a 5 out of 20 chance of pulling a blue, now have a 4 out of 19 chance, right? Because I took that blue one and I ate it, so we have 19 left total. And now we only have 4 blue ones left in the bucket. So taking them out and not putting them back is going to change the numbers we are dealing with. Okay? So we're not putting it back. So now if I pull another one, I got a red one. So remember, now our new number is 19. So we now had a 5 out of 19 chance of pulling a red. Okay? Now that I pulled that red and I'm going to eat it, our numbers are going to decrease again. So now we have 4 blue, 4 red, 5 green, and 5 purple. Okay? So when we add all of these together, we're going to get 18 total now in the bucket, right? Okay, so we now have 18 total in the bucket. Now I'm going to pull one more. Okay? I got a green. So I took that green out, right? So how many green do we still have in there? We have 5, right? So you're going to have a 5 out of 18 chance of pulling a green. Now, we only have 4 blue, 4 red, 4 green, and 5 purple left. Since I haven't replaced any of them, that number is going to keep going down and down and down because I'm not replacing anything. So that leads me into saying, oh, what happens with something when you do replace it? You do replace the item picked, okay? So I now have 20 Jolly Ranchers again, right? Same numbers. 5 blue, 5 red, 5 purple, 5 green. 5 green. Okay? So I'm going to pull out, well, I got green one. I don't really like green ones. So I'm going to put it back and shuffle it again. Now I had a 5 out of 20 chance of pulling a green, right? Is that going to change because I placed it back? No, it's not. So, when you replace an item, the values do not change. which means the chance you will be able to pull a green stays the same. That's what it means to replace. Do probability with replacement. Thank you guys for listening for this review. I hope this helped you. Have a nice morning, evening,